Oh, hey, I'm glad you're here. Take a look at this note I found with this box. 3 in a row say no. What remains, large to small, will unlock the box for all. Not exactly sure what this means yet, but I bet we should start by solving these equations. Okay, so we've been solving many different equations. We've even worked with some fractions, but equation 1 has something new. What do you notice about the equation 3 times the quantity x minus 2 equals 12? Well, the left side of this equation has a set of parentheses, grouping the expression x minus 2 with a 3 in the front. These parentheses make it kind of tricky to see what's happening to x. Can I just erase them? Well, no, I'd better not, because these parentheses are actually telling me to do something. What are they telling me to do? Oh, that's right! Parentheses in an expression tell us this number on the outside is being multiplied to the expression inside. So let's distribute this 3 times x and 3 times 2. Okay, so now I have 3x minus 6 equals 12. But wait a second, when I'm solving an equation, I do operations to both sides to keep the equation balanced. So do I need to multiply by 3 on the right to keep this balanced? Let's take a look. Recall that an equation is just 2 equivalent expressions. In this case, 3 times the quantity x minus 2 and 12. When I distributed this 3 to eliminate my parentheses, did I change the value of this expression? No, I just changed how the expression is represented, which means I do not need to change the value on the right side because my equation is still balanced. Am I ready to start solving? Now that I can clearly see what is happening to x, I'll be able to figure out which inverse operations I should use to undo it. So yes, I'm ready to solve. Pause the video now and solve this equation for x. Let's check your work. First, I added 6 to both sides, which left me with 3x equal to 18. To get x by itself, I divided both sides by 3 to get x equals 6. How would we check this answer? Right, just like before. We substitute 6 for x into our original equation and evaluate. 6 minus 2 is 4, and 3 times 4 is 12. Our work checks out. So, when I was given an equation that had an expression with parentheses, I started by simplifying that expression completely, or until the expression had no other operations remaining. That allowed me to use inverse operations to solve as usual. So, if x equals 6, let's circle this 6 until we know what to do about this riddle. Okay, we're one step closer to cracking this code. Let's take a look at equation 2. 2 times the quantity 2y minus 5 plus 3y equals 11. What do you notice? Yeah, I see another grouping and 2 variable terms. What should we do first? Well, I can't combine 2y minus 5 because they aren't like terms. And I can't combine 2y and 3y yet because 2y is stuck in this parentheses. So what can I do? Distribute. 2 times 2y is 4y, and 2 times 5 is 10. So now the expression on the left side is 4y minus 10 plus 3y. Is this expression simplified? Not quite. I still have these two variable terms, 4y and 3y. Any ideas on what I should do? Well, before, when I had two variable terms, I used inverse operations to cancel one of them. But these variable terms are on the same side of the equal sign. Do you know what I should do? Oh, right. 4y and 3y are like terms because they each have a y to the first power. And since they're in the same expression on the left side, I can just combine them to make one variable term. Did combining 4y and 3y change the value of the expression? No, the value is the same. We're just representing it differently. That means my equation is still balanced. So, are we ready to solve? You bet! We've simplified this expression. Now we can see what is happening to y, and we can undo it to get y by itself. Pause the video and solve this equation for y. To solve for y, I started by adding 10 to both sides, giving me 7y equals 21. Divide both sides by 7, and y equals 3. Is that what you have? If not, pause here and correct any mistakes. Let's circle this 3. Okay, 2 down, 1 more to go. If you're feeling confident, pause here and solve equation 3 on your own. Otherwise, follow along with me. What do you notice about equation 3? This equation has parentheses on the right side and variable terms on both sides of the equal sign. Is the left side of this equation simplified? Yes, the left side has no parentheses and no like terms. What about the right side of this equation? Yes, we have a grouping. Let's use the distributive property to eliminate these parentheses. 5 times m is 5m, and 5 times 2 is 10, so now on the right side of this equation is 5m minus 10. Is the right side simplified now? Yes, there are no parentheses or like terms. That means it's time to solve. Pause the video here and solve the equation on your own. Since the variable terms are on opposite sides of the equation, I start by canceling one of them with inverse operations. I chose to subtract 2m from both sides, which left me with negative 7 equal to 3m minus 10. Next, I added 10 to both sides, which left me with 3 equal to 3m. Finally, I divided both sides by 3, giving me a solution of m equals 1. Check your work and correct any errors if needed. And with our final solution, we can try to figure out what this riddle means. It says 3 in a row say no. What remains, large to small, will unlock the box for all. What do you think that means? The solutions we found are 3 in a row, and say no must mean we don't use those values as part of the combination. Okay, what remains large to small? Maybe we should take all the values that are left and put them in order down here from largest to smallest? Let's see, 8, 7, 5, 4, 2, and 0. I guess this means our combination is 87, 54, 20? Let's try it. It worked! I'll add these new pieces to the rest of our stack. I'm sure I'll be out of here in no time. I hope. Today, we solved equations that required us to simplify one of their expressions first, which meant eliminating any parentheses or groupings and combining like terms. Once both sides of the equation were simplified, we could solve the equation using inverse operations, just like we've done with the other equations we've been solving. When you're finished with the guided notes, complete practice levels 1 and 2. Until next time, remember, math is everywhere. Keep exploring.
Hey, hey.